All right, we're going to begin our discussion of solutions. I think the best way to talk about a solution is through this simple equation. A solution is going to be a mixture of a solute or more than one solute and the solvent. So in an equation, we can write a solution like this. The solvent in the solution is the substance in the mixture that's present in largest amount by mass, and then the solutes will be the substance present in the mixture in lesser amounts. In our class, we're almost always going to deal with aqueous solution, in which water is the solvent. So water is going to be the substance that's present in the greatest amount, like salt water or sugar water or something like that. In salt water, salt would be the solute, and water would be the solvent. In aqueous solutions, like a sodium chloride solution, we'd write it like this. We just write sodium chloride, aqueous. This means the sodium chloride is dissolved in water. There are going to be ways that we keep track of how much solute and solvent is present, and the various ways we do this are called concentrations of the solution. There's a lot of different ways that you can express the various relations of the solution, the solutes, and the solvent. And here are just a few of the ways that we need to learn how to do this. There's just 4 we're going to cover in this class. Those are molarity, molality, percent by weight, and mole fraction. And we're going to cover each of those here in turn. Molarity you've heard before. We discussed that a lot last semester. Molarity is going to be abbreviated with a capital M. So you might remember last semester I may have talked about like a 1.5 molar solution of hydrochloric acid. And what that would mean is the moles of the solute, in this case, the moles of the hydrochloric acid, for every liter of solution. So a 1.5 molar solution of hydrochloric acid would have 1.5 moles of hydrochloric acid for every liter of the acid solution that you had. The next definition that we're going to need to understand is that of molality, and that's abbreviated with a lowercase m. And the definition of molality is similar in some ways, but different in some important ways from that of molarity. The numerator of these two are the same. So the numerator of molality is mole of solute, just like it is for molarity, but the denominator is different. In molality, the denominator is kilogram of solvent. Now I want you to recognize that the denominator of molality is different than the denominator of molality in 2 ways. The unit's different. In molarity, the unit is liter on the denominator, whereas in molality, the denominator has units of kilogram. Also, what the denominator is referring to differs. In molarity, we are talking about liters of the solution, whereas in molality, we're only dealing with the solvent. So these are some important things to keep in mind when thinking about molarity and molality. We're just going to do definitions now. We'll go to problems in the next video. The next definition that we'll use is percent by weight. And this is going to be your grams of your substance of interest, we'll call it A, over the grams of solution. And by the way, sorry, this is 100 grams of solution if you want to make the math work out. So if I have like a 5% solution of hydrochloric acid, we'd say that's 5 grams of hydrochloric acid for every 100 grams of the acid solution. So anytime you're given like I said, a 5% solution of HCl, you can write it like this, and that's going to help you with the mathematics. And then finally, we have mole fraction. Mole fraction, we'll say of some substance A, that's abbreviated with the Greek letter chi, with a subscript A, so that'd be the mole fraction of A. And the way that's going to be defined is the moles of the substance A that you're interested divided by the total moles in the solution. Just put total moles here. Another way that you could write this is mole fraction of A. Let's just say there's just A and water, A dissolved in water. We would write this like this. The moles of A over the moles of A plus the moles of water. And this can be written as a percent or it can be written as a decimal.